And the recording's on, so it's our official start of big data today. And today we're going to start doing actually coding stuff, working with the terminal, working with the Lambda server, and doing some fun stuff. So hopefully it will, be a lot more fun than last class. As a reminder today, when we're going through things, it's sort of hard for me to see all of your faces and expressions and know whether things are making sense or not making sense. And so especially when we're online, I rely on your all's questions and feedback to get the appropriate pacing for how things are going. And ways to ask questions are you can always just unmute yourself and ask a question. That's totally cool. There's also the chat box that I have open on a second monitor, so I can monitor that. And if you don't feel like your question needs an immediate answer, I can get to your question right when I think it's a good fit for a good stopping point. Or you can also raise your hand in the Zoom window, and I will call on you when it's a good time. So please feel free to ask questions, and that'll help me too, again, with setting pace and things like that. Today, we're going over what for many of you will be a review, working with the Linux terminal and Git, GitHub, and we're going to go pretty fast through this material. And I understand for a lot of you that's not going to be necessarily review material, and so this might seem like an extremely fast overview of all of these concepts, and that's okay. Again, the sort of first 3 weeks or so of this course is devoted to getting everybody up to speed on these Linux terminal background sort of issues. And if you feel overwhelmed right now, that's okay. You'll have plenty of time to get up to speed. So that said, I'm going to share my screen and we'll get started. And again, everything in this class is going to be done on GitHub. We're using GitHub to manage the class because GitHub's an actual tool that people use in industry, and I want to get you exposed to these actual industry tools. I don't like using tools that are just sort of one-off things, especially things that are only going to be used in colleges that you're not going to be using in your actual careers down in the future. And in our GitHub repo, we have a folder for every week. Week 0, we're computer scientists, so we know that 0 is the first number. This is week 0, not week 1. And we're going over the Unix shell this week. I just want to remind us all of the lab and the homework too before we get started. That every week in this class, there's going to be a homework due. Most weeks there will be labs, but not every week. And the due dates are always going to be on the Sunday of the week that the material is assigned. So nominally, this lab would have a due date of this coming Sunday. But because, again, this is the first lab, everybody's still getting comfortable with everything. For this lab only, there's not going to be a late penalty if you can't get things done. So try to get things done by this Sunday, but if for whatever reason you can't, no penalty for that. And the same policy works for the homework as well for this week. A number of you have started this lab already. With the first assignment here is to do the meet and greet issue thread. Talked a little bit about issues last time with GitHub, but issues are generally the way that projects on GitHub, the way that people on projects coordinate with each other on different topics. And so in this class, all the communication is going through GitHub issues, again, to get you familiar with sort of the protocols, both technical and social, of using GitHub. One of the things that I want to highlight is that down here, as people are making your replies, I'm going to posting comments about whether, I don't know, different things about your replies. And in some of the comments that I make might seem like very terse, potentially borderline offensive if you're used to more like softly worded things. But in the computer science world, this is normal and to be expected. And I will try to, well, you should understand that everything I'm saying is, every critique maybe that I'm giving is definitely not intended to be offensive or and anything like that, but just corrective. And it's you should think of it as a good thing if you get corrected, not as a bad thing. I certainly don't think less of anybody who gets corrected. And one of the main things that I'm going to be correcting people on as we're using GitHub issues is the different like social aspects of using GitHub issues and making sure that you're communicating in a way on GitHub issues that's going to reflect your skills as a computer programmer. One of the things that you may have heard about when like you're doing interviews with companies is that they want to see your GitHub profiles, and sort of beginner programmers think that the reason for that is because people want to see your code and that you can code. And that's true a little bit, but really what people want to see is how you interact with the other people in the world. It doesn't matter whether you're like the best program in the world. If you're a pain to work with, nobody wants to hire you. And so a lot of the things that I'll be saying on GitHub issues are just like how to present yourself and interact with people in a good way. And one of the most common mistakes that people make is just formatting your code that you present on GitHub in an incorrect, hard to read way. And this generally, I don't know, just, yeah. It's hard to say exactly like why that's bad, but just makes it harder for people to work with. But the key thing here in this comment that I left is that anytime you see the word code block, that's specific for something that looks like this. So a block of code that's actually separated from the text. This is an inline code element. And it's important to get these two things correct, and always use the correct version of these to make your comments readable. And for this this first meet and greet thread, this is the sort of code block style that you'll want to be using. Today in class, the main things that we're going to be focusing on, again, are the terminal and how all this relates to GitHub and our class. But before we get into that actual technical discussion, does anybody have any questions about anything big picture with the class or using GitHub or anything at all?
Yeah, I have a question. You might cover this later related to the lab under caveat tasks,
yes.
Specifically the type speed. Can you just quickly go over like caveat tasks in general and how those relate to the entire course?
Sure. It is a great question. That there's a lot of sort of moving parts in this course, especially with how your grades are going to work. And so I'm just going down on the syllabus. So this is the README file of the main GitHub repo page right now under grades. And there's a bunch of normal assignments listed here that have different point values, and your grade is just sort of normally assigned like every other class based on these point values. But there's these two other tasks down here that I'm calling caveat tasks that I think they're very important for you all to do, but they're in some sense like easy tasks or not like technical tasks, not things that I think deserve like points, but I want to ensure that you do somehow. And so these caveat tasks, if you complete them, then they have no effect on your grade. And so I'm expecting everybody to complete them. I don't think they're going to take a significant amount of time. And there's no due date for these except that they must be completed by the end of the semester. But just to ensure that everybody completes them, if you do not complete them, then you get a 10% penalty on your grade. So like an A- would go down to a B-. And so Dustin's questions was specifically about this first task of the type speed. And basically this is just ensuring that you have some practice with touch typing in a programming environment. And so it's not like a technical skill that is, I don't know, something that I think should be graded, but it's something that's going to, I think, really improve your productivity and skills as a programmer. And so if you're not currently comfortable touch typing, then especially touch typing like weird programming terms like FSIC and TCBD check, then you'll want to get your fingers just muscle memory doing that. You hear a lot of times at like companies, they have their technical interview process, and then there's like this weird sort of culture fit thing. Anybody who's not a touch typist is going to fail the culture fit at any company, just because it's really frustrating to work with somebody who is slow to get their thoughts on the keyboard if you're doing pair programming or something else. Did that answer your question, Dustin?
Yeah.
Perfect. Any other questions at this point? Okay, then I'm going to switch my screen over here to the terminal. And let's see, I think Zoom might be blocking the top of this for you. So let's change that size a little bit. And currently I'm logged into the Lambda server on this terminal, and we're going to be just going through some different commands. All of the different commands that I'm going to be working with here are things that I'm expecting you to maybe not immediately have full comfortness with, but throughout the semester, you'll get more and more comfort with these commands. And there's also not going to be like a specific test on any of these commands, like what does command this with these parameters do. It's just, I'm going to use all of these, and you're just going to be expected to be able to keep up with what I'm doing. And so the first command, most basic command at the terminal, is the ls command. Ls stands for list, and lists all the files in your current folder that you're working on. All of your folders should have come with this big data folder inside of it. And your accounts have 250 gigabytes allocated to this big data folder that you're allowed to work with throughout the semester. And the different homeworks will have you doing things in that folder. And then if you're in your home folder, then you have 10 gigabytes to work with. The home folder is located on what's called an, so the big data is on what's called a RAID array of HDDs. In the terminal, anytime you have a hashtag, this is a comment, so this command does nothing. I'll occasionally just be typing comments into the terminal like this so that you can see how things that I'm saying are typed out. And then the actual, the main hard drive for this computer is what's called an MVE hard drive. And so HDDs are sort of like the slowest possible storage that people regularly use in practice, common for just like archival purposes. NVMEs are extremely fast, and so faster than like RAM main memory was about 10 years ago. And so when you're working in your home folder, there'll be no bottlenecks about like input output sort of things. But when you're working in this big data folder, things will be a little bit slower. We'll go over exactly what these things mean in more detail as we go through this course. The next major command to be aware of besides ls is the cd command, cd standing for change directory. And I always have in my systems a proj folder, short for projects, that I keep all my GitHub repos in. And so we're going to cd into this proj folder, and you can see right now I have a whole bunch of projects like this. If you wanted to make a new folder on your own account, the way to do that is with the mkdir command, make dir proj, type ls again, and now you can see up here there is no proj folder anywhere down here. We just added this proj folder. If you want to delete a folder, rmdir proj deletes that folder. It no longer exists. The way to check that it no longer exists, I can type ls like this, or as you get more comfortable with the terminal, you start learning more shortcuts that you can do to save yourself some typing. And the most important shortcut to know is the up and down arrows on your terminal. So press the up arrows like this, it takes me to the previous things that I typed in, going up the screen. And if I press the down arrow, it takes me down the screen, down the commands that I've typed. So these commands are all relatively short, but eventually we'll be getting commands that are like maybe 100 characters long. It's a little bit awkward to type those out again if you don't have to, and the up and down characters or the up and down keys get you to your previous commands. At this point, what we're going to do is I want to download our class GitHub repository onto my Lambda server account so that we can edit things and work with things and get some review of Git as well. The command for doing that is just git clone, like this. So git space clone. When we have the very first, every time that I'm typing a command into the terminal, the very first thing in that command is the actual name of the command or the name of the executable. And the second thing, or all subsequent things, are parameters to that executable. So git is the actual name of the program here. Clone is the specific action I'm doing with Git. And in a little bit, we'll see more different actions that you can do with Git. And then I need the URL of the project that I want to clone. So it's https://github.com/mike-hisbicky/cmc-csci143. And I hit enter and prints out some debugging information. And now if I type ls again, I have this, this folder right here. And you can see that as I was just preparing things for the lecture, I had made some old folders as well that just to check that things worked correctly. I want to go into this class folder next, and so I'm going to do cd cmci csci 143. You notice that when I type just the C like this, I'm not sure how laggy Zoom was for all of you, but it might look like I was an extremely fast typer, and I'm not that fast of a typer. Instead, what I did was I just pressed the tab key on my keyboard, and it completes the name of a file as long as the name would be unique. So there's a handful of different things that I have in here that start with CMC. And so if I did just CMC like this and press tab, it'll add this -csci because all of these file names right here contain -csci inside of them. But it doesn't know like what to keep going with. It could be like 046, another class that I taught that it wants to add. It could be 143, 143 old, or old 2. And so it's not going to keep going. At this point, if I wanted to get into this one right here, I have to type the 1 and press tab again, and now I have that folder name. If when I'm right here, I press tab multiple times, it shows me a list of all the possible things that that I might possibly want to type next. This idea of tab completion is what it's called, what I've been doing, pressing this tab key to make typing out file names faster. This is one of the habits, sort of the muscle memory things that you want to get really comfortable with. It'll make you a lot more productive when you're using the terminal. And in two ways. First, it's just faster to type things. You don't have to type out all of these characters. You can just type out a couple and press tab. But even more important, it saves you from like making typos, and really easy to make typos. There's a good question in the chat about should the projects folder be inside of the big data folder or outside of the big data folder. And my recommendation is to keep it outside of the big data folder. And my recommendation actually for everything that we do in this class, unless I tell you specifically to put something in big data, keep it outside of the big data folder, just inside your home folder, because the NVMe drive is really like, it's hundreds of thousands of times faster. And so you'll never experience any sort of lagginess or problems like that if you're with things outside of the big data folder. But things inside the big data folder, you will have some lagginess working with. So yeah, the default is keep things outside of big data. Good question. Let's see. So we're inside of my Git repository now. And one of the things that you'll notice is that after I've CD'd into this folder here, on my terminal, this whole thing down here is called the prompt. on the prompt on my terminal, that's the prompt. The prompt on my terminal has this purple thing right here that tells me what's called the branch that I'm on in a Git repository. And up here, I was not inside of a Git repository, and so I only had this green text that showed me what folder I was in and the name of the computer that I'm currently on. But as soon as I entered the Git repository, I have this information about what branch I'm on, and we'll talk about what this means. Probably not today, but eventually. It's basically telling me how the code on my computer relates to the code that's uploaded on GitHub. But we're going to pause the terminal here. So I'm going to go to the GitHub webpage, and we'll see a little bit more about branches on the webpage. So I'm back on the GitHub webpage now, and I'm going to scroll up to the top. And over here, there's this drop-down box right here. And this is where you can select different branches of a GitHub repository. And these branches are a common way to organize projects. And every company has their own different philosophy about how branching works. And this is the sort of thing that people get both very philosophical about and very opinionated about and like very combative about. That as a junior person starting at a company, you just sort of go along with whatever everybody else is saying. But once you get more senior, you'll be like, so I've literally seen people throwing sandwiches across the room at people who they disagreed about branch philosophies with, because it's just like that important to some people's identities. But here you can see that, so we're currently in the 2022 spring semester, so I have a branch for this semester for our class. I also taught this course last year, 2021 spring, and so if we click on that, it would go back to last year's version of the course, and if you wanted to, you could see all of the different course material here. But the fact that Git lets me go back and forth between these two branches, these two like versions of this code, makes it really easy for me to organize my classes and make sure that I can pull assignments from old versions of the classes and not like have to ever lose any information. As we go through the projects in this class, you'll be doing different branching strategies for different things in this course, and getting more comfortable with doing these on your own projects. If we go on to, so the next thing we're going to do is we're going to, click under week 0 here, and we're going to start talking a little bit about the homework for this class. The question is, so there's a question in the chat about, can you download different branches in the same repository on your local machine? And the answer is yes. So I'm going to switch back to my terminal over here, and let's see a little bit about the different branch commands that there are in the Git terminal. If I type git branch, so previously we've seen Git Clone, here's Git branch. It lists the different branches that I have, and in particular, it lists only the branches that I currently have locally on my own computer. Git branch.a lists all of the branches that my computer knows about. And when you see this remote/origin, this refers to something on GitHub. And so here are the different branches on GitHub that we happen to be able to see. Something that doesn't have this refers to something just on your own computer. And there's a command git checkout that lets you switch between branches. And the lab sort of goes into a lot of detail about reviewing these different commands. That's going to take us a little bit far afield from the things that I want to talk about today, though, so I'm not going to do this quite yet. Let's see. Yeah, okay. So every week I mentioned that we're going to have labs and homework assignments. The labs are always going to be posted into the README file for the week itself, just like this one is here, and whatever the instructions are just going to be listed right here. Homework assignments, though, are always going to be in what looks like a folder up here. that, whoops, didn't mean to click that button. Looks like a folder up here, but it has this @ and then this weird random number over here. And I'm going to click this here in a second, but before I do, let's pay attention up here to the URL in my address bar. And you can see right now that it has the, oops, probably Zoom might be blocking it now, but it has the actual CS143 number inside it, our class repo. If I click on this, it's actually going to take me to a totally separate repository called the Continuous Integration Repository. And this repository walks through some basics of using branches and GitHub with your homework assignments, and in particular, this idea of continuous integration. Continuous integration is something that every company, every tech company uses to make sure that their code actually runs correctly in production. And so that's what we're going to be using in this class on all your homework assignments to make sure that your code is correct. And basically, there's a bunch of test cases programmed into this repository. You're going to have to modify this Python file right here so that it passes those test cases, and GitHub is going to automatically check those for you and tell you if you pass or fail the test cases. Right now, you can see there's this, it's called a badge right here. This red failing badge means that my test cases are currently failing, and once you fix the Python code, this badge will turn green, and then that tells you get a full credit on the assignment. Yeah, that's a super high level overview of what this continuous integration stuff is doing. You'll get a better feel for it as you go through the assignment, hopefully. And we're gonna see a little bit more of that here in a second. I'm going to switch back over to the terminal, and we're gonna see what this homework folder looks like in the terminal right now. So currently, this is what's called my current working directory or present working directory. If I type pwd, that tells me the current location that I'm at on this Lambda server. My current user account is called user test. That's what the user account I'll be using for most of the lectures in this class. If I typed who am I, it tells me that my user account is user test. This location right here is called my home folder. If ever you type cd by itself, it takes you to your home folder. Anytime you want to go back to a directory that you were previously located at, so I could type cd prod/cmc-csci143 like that. That's a lot of typing though. I'm pretty lazy, so cd dash will take you back to whatever the previous folder was. So you can do cd dash instead of typing it all out. But currently, if I'm in my folder like this, and I wanted to go to the week 0 folder and take a look at the homework folder. So cd week 0, ls, and then here's this homework folder, and do ls homework like this. Oops, maybe cd homework, and then ls. So you can see that I'm in this homework folder, pwd, inside this homework folder. But when I do ls like this, I'm not getting any results. This homework folder is what's in Git terminology called a Git Sub Module. Git Sub Module. The naming of Git Sub Module is really confusing, and I don't know the historical background for this. I've tried to uncover it, and I can't. So I don't know why it's called a submodule, because there is no such thing as a module in Git. There's only submodules. But the idea of a Git submodule is that it's this repository inside of a repository. So over here, this continuous integration repository is inside of this week 0 repository. So this right here, this homework is a submodule. A subrepo seems like it should be a better name to me, but it's called a submodule. And in order to get access to submodules inside of Git, there's this sort of arcane sequence of commands that you can run. I'm going to show two ways of doing this. One that's maybe a little bit more obvious. The more obvious one will be the second way that I do it. And the first way is the arcane sequence of commands. So in order to make this folder right here actually contain something inside of it, by default, submodules contain nothing inside of it. I have to run the Git Sub Module init command, which tells Git to become aware of the submodules that it's using, like this homework. Currently, there's a submodule in the week 0 and week 1 folders, and so that's why there's 2 submodules here being initialized. And then I run Git Sub Module update like this. And that actually sort of does the cloning into those submodules. Type ls, nothing's changed here, but now if I go cd back into homework and ls, we can see that it actually has some stuff inside of it. And so now I could actually like open up this fixme.py file and work on it. Again, I've covered a lot of things really quickly so far. And so if you haven't fully followed along, that's again, 100% okay. My recommendation is to, if you're in the place where this is feeling a little bit overwhelming, to start on the lab after lecture here and start working through things, and then maybe come back and revisit the lecture. Again, the lectures are always going to be recorded and posted onto YouTube, so you'll have those as references that you can come back to and see, like, I totally forgot what this Git submodule thing is. How can I go back and what were the commands again, or how does it fit into everything else? You can come back and watch this section of the lecture again if you need to. That said, are there any questions that people have so far?
Yeah, could you remind me what Git Sub Module update does, Professor?
Sure. So the question is exactly what is Git Sub Module update? And the answer is that when you first run Git Clone, these submodules are empty in your repository. So this homework folder was empty. Then I ran 2 commands in order to get contents into this folder. The first command was git submodule init, and the second command was git submodule update. It's fine to think of those as basically like one unit. You always do both of them at the same time, and it just puts stuff in this homework folder. Technically, it's divided out into 2 separate commands because this one just tells Git to enable the submodule procedures, and it doesn't actually connect to the network. And so if a submodule is particularly large, like multiple gigabytes, you might not want to download it. And so Git submodule init doesn't actually download anything, but Git submodule update does actually download the contents into all of the different submodules that you're using. So these 2 commands together, git submodule init, git submodule update, actually update your homework folder so that you have access on the Lambda server to the homework itself. Good question. Any other questions so far?
So if the submodule has changes, but you've also made changes on your local machine, how does that work? Is it also using branching?
Yeah, that's a great question. So the question is, what happens when the submodule has made changes, and how do you get those changes basically back onto the Lambda server? Once you've done this git submodule init and git submodule update, then this submodule here is treated as its own totally separate Git repository. And essentially, now that I've CD'd inside of this folder, Git has no knowledge that it's actually inside of the CS143 repository. It's just this submodule. And so I can run commands like git branch or git pull or any of those Git commands, and it happens just on this this submodule. In this class, you won't need to do that, I don't think. or if you do, I will give you explicit instructions on how to do that. The main takeaway is just you need to do these two things in order to, if you want to populate this homework folder. And this is also related to, I mentioned that this is sort of like the complicated way of getting access to these submodules with like arcane sort of commands. I'm going to go now and do the potentially simpler way. And whichever of these two ways makes the most sense to you is fine, and you're allowed to do either of these ways. In the second way, let's start by seeding into my home folder like this, cd into proj. And if we look down here, there is this continuous integration folder right here. I'm going to go ahead and delete this folder. In order to delete a folder, we said before that you can use the rmdir command, continuous integration like this. This rmdir command requires that the folder be empty in order to delete it. There's stuff inside of here, so ls continuous integration, so we can't delete it as it is. If I want to actually delete it, then I have to use the rm-rf command. By default, rm only deletes files, not folders. So you will get this error message saying cannot remove continuous integration. It's a directory. In order to actually be able to remove it, I add the -r. -r stands for recursive. Recursive, if you remember from your data structures, means like continuously doing stuff over and over again. And so it'll go inside and delete this, and then go inside of any subfolders, deleting those, and so on. If I run this by itself, you'll see that there are what are called write-protected files in here. And so you'll get a whole bunch of obnoxious yes/no questions. And so that -f stands for force, and that will actually delete it. Anytime if you're having trouble remembering these sort of shell commands, sometimes called Unix commands or terminal commands. So these are shell, Linux, terminal, Unix commands. There's a number of good resources that you can use to remember these things. The sort of standard resource that everybody sort of recommends is the man page. You type man and then the name of the command that you want to use. And it shows you all of the different options that you have, like -- force. If you're not like actually already familiar with these commands, the man page isn't super helpful. It's a good reference for more experienced people, but not a good tutorial. And just Googling like, how do I delete a file? How do I delete a folder on the terminal? It'll come up with this rm-rf. That's yeah. So turn to Google first, and then it'll help you with these things. But yeah, so I deleted this continuous integration folder, and the reason I did that was because we're now going to create a new one. So Git Clone, and over here, click this homework folder. It takes me to the continuous integration repo, and I'm just going to copy and paste the URL to this repo. Notice that I'm not copying and pasting the entire URL. I'm copying and pasting just the part that is the URL to the repo itself. And Git Clone, paste that URL right here, hit enter, puts it inside of this folder, and I can see the continuous integration like this, and I have access to the contents like this. So all of your homeworks, depending on which way seems more organized to you, you can put them directly in your project folder by cloning them directly, or you can go into your the appropriate homework folder of your class repo repository and do the submodules thing to get access to them there. And either way is fine. Let's see, one more sort of, I don't know, kind of fun thing about Git that I want to point out is, well, let me back up. So with these Git repositories, one of the advantages of using them in our class is that other people can contribute to the Git repository. But these are not something that are, so if things are on Sakai, then it's basically only the instructor can contribute to the class. And if there's a typo that you see that the instructor doesn't, you can't fix that typo anywhere. But here you can see that down here on the right-hand side of this repository, there's me who's contributed to this class, and then there's 2 others, former students from last semester, who contributed to this repository, fixing different typos or other things that I had somewhere in these files. And so this contributors list is stored directly in the Git repository, and it doesn't follow submodules. So there's a number of submodules as well, and other students have contributed things to those other submodules, but they don't show up here in this contributors list. And what I want to highlight here is that if we go over to week 0 and go on to our homework, then down here you can see that so Linus Torvalds, the sort of original creator of Linux, is one of the contributors to this continuous integration repository. And I don't actually know Linus, and he did not actually contribute to this. But I want to show you sort of maybe one of the weaknesses of Git, just as like something that you should be aware about when using Git. That it's really easy with Git to fake a lot of things, and that's intentionally done. It turns out that a lot of the advantages of Git, you can provably not get those advantages unless you also have these weaknesses. And so what I'm going to do is I'm going to come over here back to our week 0, the Unix shell. I'm gonna go through the process of making a change to this document through the terminal, and then I'm gonna go through the process of attributing that change to Linus Torvalds. So the first thing that's the most important thing is we have to figure out if I have one of these files that I want to change, how do I actually make the changes to that? You might be used to using a graphical text editor or an IDE environment like VS Code or PyCharm or idle. But in this class, everything has to be done on the terminal, and so you can't use one of those these systems. The most popular text editor for the terminal, and I might be starting a flame war here, but the most popular, and I'll go ahead and say the best text editor is Vim. Emacs is the other contender. Emacs is the other contender. And with Vim, if you want to edit a file, you type Vim and then the name of the file, in this case, readme.md like this, and it opens up the file so that we can make changes to it. Using Vim is, it's not easy at first. It takes a lot of practice. And there's this sort of running joke in programming circles that that people sort of get stuck in Vim and they don't know how to quit Vim. So the first thing that I'm going to teach you right now is how do you quit Vim? And the answer is you press the colon key on the keyboard. So the colon is the 2 dots right above each other on an American keyboard, just next to the enter key, and then Q. Colon Q will exit Vim. And one of the first tasks in your lab is to go through some practice of using Vim so that you can just get comfortable with the system. There's a lot of weird quirks about it that, yeah, it's just hard at first, steep learning curve, but eventually you will learn to love it. And the task in the lab is called Vim Tutor. You type Vim Tutor like this, and it opens up a Vim window with some instructions. You just follow those instructions, and it teaches you how to use the system. The tutorial says that it takes 20 to 30 minutes, but if you've never used Vim before, I would expect it to be like maybe 1 to 2 hours is what it might take. So Vim, readme, and now I'm going to edit this file to say that I've made a change, happy face, like that. when I was doing this, so right now I'm in what's called normal mode of Vim. When I touch touch any key on my keyboard, it moves the cursor around in different ways. There are cool shortcuts to move the cursor around quickly, jumping to different lines. And as I'm working through different things in the class, I'll be mentioning different shortcuts and things that you should, that you can start adding to your repository of things that you use. But for now, we've just made this simple change, and I'm going to save the file and quit. So :W, W standing for write, and then Q for quitting, like this. And you'll notice that down here in this command prompt, this little symbol down here is changed, indicating that I've made some changes to my Git repository. There's the command Git Status, like this, which tells me all of the different changes that I've made. Something that is not staged for commit means that that is the change that I just made, and Git is not aware of this change yet. In order to make Git aware of this change, it's a two-step process. The first process is adding the file that I just modified with git add, and then the name of the file, like this. Now, if I run git status again, you can see that this line is in green, and it says that this change is ready to be committed, but it is not yet committed. The next step is to actually make that commit with git commit, like this. And if I hit enter, then it will open up a Vim window for me where I can type what's called a commit message explaining what the changes I've made are. Modified week 0 readme escape :WQ and save that. There are a lot of there's another thing that people get into very heated sort of debates about is how do you structure a commit message to be useful. And we'll be talking about like the purpose of these commit messages, how to use them, and maybe giving you more informed positions about that debate as we go through this semester. At this point, if this is all just sort of like gibberish, again, that's okay. You just basically need to memorize that these are the steps. Anytime you're making a change to something, you use Vim to edit it, then you git add that particular file, and you git commit it. When you do that, the change has been updated locally on your own computer, but it has not been updated remotely on GitHub. If I switch back over here to GitHub, refresh this page, you can see that there's been no changes to this file. In order to make those changes actually permanent, uploaded where everybody can see, I have to do what's called pushing those changes, git push, and then origin, and then the name of the branch. In this case, 2022 spring, like this. Hit enter, have to type my username, Mike is Vicky, hit enter. And then it's gonna ask me for a password. Those of you who take CS46 with me, you should make sure that you're paying particular attention right now, because since last year, Git has made some changes to how they handle passwords. And in particular, this password that you type in right here is not the password that you use to log into GitHub anymore. Now this password is supposed to be what's called a personal authentication token. And if you follow the instructions that I have linked in the lab, it'll tell you how to get one of those. But just know that this step right here is a little bit different than it used to be. I'm going to type my personal authentication token in here and hit enter. And we get some nice messages saying that everything worked correctly. If I switch back over to Firefox and refresh this, then you can see now I have this message saying I've made a change, like this. Any questions at this point? Okay. So I promised I was going to make Linus Torvalds one of our contributors to this project. So let's real quickly add this. I've made a change. Linus made a change. Escape :WQ, enter. We're made a change to our repository, so I need to do git add, readme, now I do git commit, and there's these special commands that I can do. This -c stands for configuration, and I can set my user.name equals to Linus Torvalds, and -c user.email equals Linus's email, Torvalds at linuxfoundation.org, like this. By default, Git is always going to ask you the very first time you run Git on your computer, if you don't add this username and password, it's going to complain saying it doesn't know who you're committing as, and it's going to give you some commands that you can run to make it so you don't have to type in this information every time. But if you don't run those commands, then you're required to type in your username and email every time. And you notice that there's no like password or anything that I'm typing in here, just username and email. And then we'll do our commit. Whoops, should be git, then the -c's, then the commit, and then we'll add. Before I did a commit all by itself. Now if I do this, it opens up the Vim window. If I have a really short commit message, I can add the -m flag right here to just say Linus commit, like that, and hit enter, and it doesn't open up Vim. Just this right here will be the commit message. And now so I've done the add, I've done the commit, and I can do the push. That push command, it was a really long command. I don't want to have to type that whole thing in again. And so what I often do is I press Control-R on the keyboard. So let me type this out in that comment right here, Control-R, like this. So press Control-R, and you see down over here in the bottom left, it changes my terminal prompt to say reverse iSearch. And this lets me just start typing in a command like push, and it will search all my history of commands that I've typed in recently and see whatever command contains this word. Here's the command that contains that word. And now all I have to do is type push to get access to that command, hit enter, and it runs that command. Once again, type in my username and my personal access token. Notice this was not Linus's username and Linus's personal access token. It was mine for my account. And everything got pushed up there fine. Refresh right here. Linus made a change. If we come back over to the main repository, refresh. So I have to click that button here. And there's Linus Torvalds, who's committed 2 lines into my repository right here. So it turns out, again, for various important cryptographic reasons, it's impossible for Git to prevent people from impersonating other people on with their commit messages in Git. And so if you want to have whoever you want committing to your repositories, you can do that. And you can't trust that just because you see somebody has Linus as their committer to their project doesn't mean he's actually done that. Hopefully, if you've used Git before, this is jogging your memory about a lot of things, and so the lab will be pretty easy to do. There's a lot of stuff in the lab that we haven't covered in this part of the lecture, though. So yeah, if you do come into problems working on the lab, then I'll have lots of office hours next week. You can stop in and we'll spend lots of time working on that. Questions, Hannah?
Yeah, Professor, I was just like making sure because I was jotting down notes. I was just the Vim I never actually used them before, so it's my first time. I remember you saying that you press escape character and WQ to exit. Is that right?
Yeah. So if you open up Vim, :Q quits, :WQ saves and quits.
Okay. But how do you get to the last one? Do you like just press, or you can do, there's a fast track to just go to the last one? Because from
so if you're in a file, how do you get to the last line?
Yeah, because I noticed that you are line 1 right now and you just like pause.
So Shift G takes you to the last line. GG by itself, 2 lowercase g's take you to the first line.
Okay.
And I'm glad you brought this up because I forgot to mention that over here in our week 0 folder, there are 4 cheat sheets down here that are listed. And I'm basically going to be expecting that everybody is familiar with all the material in these cheat sheets. So I recommend having those printed out and handy for lectures or while you're just working on assignments that at least at this point, you don't have to have all those things memorized, but certainly by, say, like the halfway point of the semester, I think the expectation will be that you basically have those cheat sheets memorized with all the contents in them. And here in the Vim cheat sheet, you can see there's a bunch of these shortcut commands that do different things. And this capital G right here, go to the end of the file, is one of them.
All right. Thank you so much.
Yep, that's a great question. Any other questions at this point?
Yeah, I have a question about the lab. So one of the steps requires us to count the number. We were analyzing Twitter data set. I was wondering if you could show us like.
Yeah. So very last part of class today is, let's see, so at this point we've reviewed everything up to this step 3 in the lab. And very last part of class today, we'll talk about this step 3. The basic idea of this step 3 is that so this terminal, this bash environment is extremely, extremely powerful. And a lot of, I don't want to say beginning programmers, but beginning Linux users feel nervous about the terminal, feel like, why do I have to learn this terminal stuff? But the reason is because it's just so powerful. And this is just giving us a hint about this power. And so let's talk about that. Inside, there's a folder ls/data/Twitter dataset that contains a whole bunch of tweets, several trillion tweets that we'll be using throughout the semester. And if I just hit enter, you can see these tweets are all stored in zip files with 1 zip file per day. And it's got all of the tweets since, I think, 2017 that have ever, like all of the tweets that have been sent. And you'll notice that, let's first do, let me just cd into this folder here. This folder right here contains a space in its name. Over here, there's a space. And anytime you have something with a space in it in the terminal, you can't just type space. You have to escape that space somehow so that it knows that this is just a single file name and not 2 separate names. There's multiple ways of doing that. One is that you can put a backslash in front of the space. Here, when I did /data/Twitter dataset, I was using tab completion. I just typed the capital T and pressed tab, and it completed it for me like that. And the tab completion uses the backslash space option. Another way you can do this is cd and then putting it in quotes /data/Twitter space dataset like this. And these 2 things are 100% equivalent in bash. But that's one of the tricks on this part 3 is that when you see something referencing Twitter dataset, you'll have to put it inside of quotation marks because of this space. The next thing is that there's a bunch of these zip files. And we're going to, I'm going to open up one of these zip files, Vim, Geo, Twitter, 22-01-17, say, a couple days ago, .zip. And Vim can open zip files for us directly. You can see inside of these zip files, we have, there's like 1 file per day. If I just hit enter, it's going to open up the zip file for that particular day. And the information is stored in JSON format, where each line of the zip file contains a JSON object that represents all the information in the tweet, like this. So :Q, let's break out of that. And the that part 3 task, the part 3 assignment asks us to analyze these the zip files. The way we do that is using pipes. So recall that ls lists out all of these the files in a folder. If I were to do ls-l, the -l causes it to list everything out one line at a time, and it provides some other extra information about the files. Right now, so next week we'll see what this other information is, but right now we don't care about that. We just care that there's one line per file. In order to count how many lines there are in the output of this program, I can use what's called the WC command, WC. If I use WC just by itself, so WC stands for word count, we'll get just some empty lines like this, type some things in, and then I press Control-D to end the program, Control-D to end the program. So you might have used Control-C for other things before, not Control-C. And it outputs some information about some statistics about the file. WC-L specifically tells me how many lines were entered. And so there were 8 lines that I entered right here. One of the principles of Unix, which we'll be pounding through or hammering into you throughout this course, is that all the programs on the terminal can be connected to each other through what are called pipes and redirection. And so here, if we did ls pipe wc-l like this, it'll take the output of the ls program and send it to the input of the wc-l program. And so I can see that there are 1525 lines as the output to ls. So there are 1525 files in this folder. Right now, this includes all of the zip files, and it includes these 2 extra files over here. If I want to only include zip files, there's a program called Grep, which I can use, Grep, and then I put in some regular expression right here that lets me filter out the output of this so that it only contains certain things. So in this case, I would want it to only contain the .zip files. So let me compare the outputs, the outputs of these 2 commands, ls pipe grep.zip, filtering only these red files, only these zip files, 1523 of them, and ls without the grep, 1525, because there are 2 of these extra files. Again, the required, or the links in the lab give you some more explanations about how to use these pipes and examples and different clues. So go through those. Hopefully that will remind you of things that you've already seen before, or if you still have questions after working through those, again, a lot of office hours time next week to work with you that are in small groups or one-on-one to fill in whatever the missing gaps are that either you've not seen before or have forgotten since last time. I will have it in a second here, pause to answer questions that people have, but we have on Fridays a little bit of a weird schedule of 11 to 12:05. For whatever reason, that's the time slot that they gave us for our Friday times here. And so we're out of time, and that will be our end of class today. We've reviewed again everything that you need for the labs and the homework. Hopefully this is ringing some bells from your previous classes. But again, even if you haven't seen any of this at all before, you'll have the next couple weeks to get all this sort of stuff mastered, and I'm happy to work with you all to meet those needs. So that's the end of class officially, but I'll stick around and for as long as people continue having questions about things to answer those questions.
Thank you, Professor.
Thank you.
Thanks, Mike.
Thank you.
You're welcome. Anybody have questions? Joey?
Yeah, so on the Lambda server, I don't have
the big data folder.
Oh, that's
and
right.
yeah,
Okay, send me an email to remind me to give that to you. You won't be needing it for a while though. So
okay, cool.
yeah.
Sounds good. Thanks.
I had a quick question. So if we're all cloning the class folder, are we all working on the same branch, or do we make our own branch, or how would that work?
Yeah, it's a good question. So for so the class folder, in order to say make a change to something that I have, currently you don't have permissions to write to that that repository because it's under my username, and you'll have to go through what's called a pull request in order to suggest a change to it. And one of the lab links walks you through the pull request steps, and you'll make a pull request to the class to do that. The short answer is that everybody's going to be working under the same branch names, but you'll have actual different repositories that you're working in, so things won't end up conflicting.
Oh, okay, got it. Thank you so much.
Yep.
Hi, Professor Vicky. I was just wondering, I just permitted the class yesterday, so I don't think I'm on the Lambda server yet.
Yeah, can you copy or put your email into the chat window, and I'll go ahead and get you set up with a user account and email you your credentials.
Sure. Okay. Thank you so much.
Okay, the account's created. I'm just getting the email sent to you right now. Okay, email's been sent. You should, I don't know, a minute or so, however long it takes, get it, and then
just got it.
And then be able to log in. Perfect.
Thank you so much. Have a great day.
I'll just go. So for this week, we actually have a lab and a homework, right?
Yeah, so the due dates are technically Sunday, but there's no late penalty. So if you can't get it by Sunday, that's okay.
Yeah, I still have a lot to catch up, to be honest. Like I did like my I would call it I did like data structure in C++, so there's a lot of new things, but some of them seem familiar because I use Git Sub a lot for like my side projects. But some of them are also like really new, so I'm just gonna take a little time to like brush it up and catch up for this week. I was just like trying to let you know. So definitely like next week I'm gonna be in office hours. It's like an hour before class, right? It's actually an hour after class.
Yeah. The Monday, Wednesday ones are after class, and then Friday would be before class.
Okay. I will definitely like try to jump the session like to catch up a little bit, and I will try to like also be done with that assignment. But regardless, I'm gonna be at office hours. Thank you.
Yep, sounds good.
Hi, Professor.
Yeah.
Sorry, so I'm not also on the big data file as well. So I was just wondering if you could add me onto that, because I think when you were going through the code, I was trying to like get that on here with like on the terminal, but I couldn't. So if you could add me on that.
Sorry, add you to what?
So the big data folder, like a file. Sorry.
Okay, let me see here. What's your username?
DABALUS.
I see it now. It looks to me like you have the big data folder. Can you share your screen with me so I can see what you're looking at?
Okay. 1 second. Okay. Let me go back. I was looking, oh, this one.
So the big, if you log into the Lambda server, that's where you'd find the big data folder.
I logged into that already.
And so if you type ls right here and hit enter. So yeah, there's the big data folder. This is different though than the Twitter dataset folder. So if, up the command you're getting before, you're getting this error message, no such file or directory, because you have Twitter dataset without a space. I see that you have the backslash, but it should be Twitter \space dataset.
Oh, okay. Okay.
Does that make sense?
Yeah, that makes sense. And also, I think some of these I've taken, not data structures, but I've taken some other classes that just look a little bit similar. So I think I will have to brush a little bit on that and then get my thought process start like running. But I was just also wondering with the labs, and then if if I wanted to go like for mentor session or something, when are there, like, is there, besides office hours, are there like mentor sessions where you get to like work with a recruiter or something?
Yeah, we do have two tutors for this course. They QCL hasn't set up like their schedule yet though. So as soon as that's done, I will let everybody know. But so yeah, I'm hoping next week.
Okay.
That it should be set up, but it's not set up yet.
Okay. And also, I think I would just take time to like go over the tutorials first, even before coming to like work on this one. So that way, by next week, like when I start working on it, I have questions I can come to.
All right. Yeah, that sounds good.
All right. Thank you. Thank you so much.
You're welcome.